Hi everyone, my name's Noah, and in this video I'll be demonstrating one of the new features in the Elements Series 3 programming system, the ability to create a parallel program. Before we get started, let's clarify what a parallel program actually is. Essentially, a parallel program is a logic processing program that can execute multiple tasks simultaneously and operate independently from robot projects. It can monitor signals, positions, forces, and other states while the robot is active. It also enables real-time communication and control of external devices. An example use case for a parallel program would be if you're creating a polishing application with one of our Ryzen robots. You program the robot and you already have your off-the-shelf rotary polisher, so you're already 95% of the way there. But what happens if, while the robot is polishing, let's say, a car door, your colleague accidentally walks into it? And by it, I mean the robot, not the door. Although our robots can dynamically respond to external forces, in most applications, users want to immediately halt all motion when something unexpected happens. So, the robot would stop moving, but the polisher wouldn't, since it's just a standard power tool. This is where a parallel program comes in. With a parallel program, as soon as the robot experiences an unexpected stoppage, it can send a signal that can instantly turn the polisher off. This would stop the polisher causing damage to the paintwork. Now that we know what they're for, let's create a parallel program step by step. First, we navigate to the application page and then to the parallel program interface. Here you can see the status of existing parallel programs and create or import new ones. Let's start by creating a new parallel program. We'll name it Safe Stop. After that, we'll open the editing interface for the parallel program. The editing interface provides a comprehensive set of instructions, including signal control, loops, logical operations, math operations, robot operation, text operations, list operations, external communication, and a range of other useful features. In this case, we'll use the logical instruction if-do. So, if a robot stops running, the program can send a signal to shut down the polisher. Then, under Robot Operations, select System Variable. From there, choose Project Running. Next, we'll set the state to fault, meaning the robot stops running. We can then change the value from true to false and connect it to the if statement. After that, we need to turn off the polisher's signal. To do this, we select GPIO output port 5, where the polisher is connected, and set its signal to false to turn it off. By simply dragging and connecting these logic blocks, we've completed the programming for this parallel task. With that done, click Save and activate the parallel program. After activation, you'll notice it stops almost immediately. This is because we need to adjust the run settings in the interface. To do this, select Loop Run so the program runs continuously. Now, when we restart the program, it will keep running. Alternatively, you can choose Auto Run, which starts the program automatically when the robot powers on. You can review or manage the program at this interface. For the more advanced users, you can switch to the debug panel to view the program script. On the dashboard, you'll also find the parallel program icon, where you can quickly check the status of any parallel program. Alright, let's start the polishing program and simulate an abnormal robot stop. In this case, I'll hit the E-stop. As you can see, as soon as the robot stops, so does the polisher. That's all for this tutorial on parallel programming. If you'd like to learn more about our robots, stay tuned.